Hello guys, so today I'll be explaining the CQDs of chapter 8 notes. Okay, I explained in the previous video, I did a quick summary, okay, of chapter 8, and now I will explain the questions. So the very first thing we start with is the bond energies. First, let's read the question. Calculate the enthalpy change in kilojoules per mole of the reaction between ethane and chlorine given the bond energy values. We said in the previous video, anytime we see bond energy, it is the heat of reactants minus the heat of products. How do we denote bond energy enthalpy change? It is delta H. So us, we need to find delta H, or the difference of heats, by doing the heat of the reactants minus the heat of the products. So first of all, let's find the heat of the reactants. We have, in the reactants, we have 1 C double bond C plus 4 CH. So we have 1 C double bond C and 4 single bond H, okay, plus 1 single Cl bond. So if we're going to replace the values, we're going to have 1 times 602 plus 4 times 413 plus 1 times 240. And if we're going to place the values on the calculator, we are going to get 2494 kilojoules. All right? So now we found what? We found the heat of reactants, which is 2494 kilojoules. Now, let us find the heat of products. In the products, we have 1 C single C bond plus 4 times C single bond H plus 2 times C single bond Cl. So if we're going to replace with the values, it's going to be 1 times 346 plus 4 times 413 plus 2 times 327. So on the calculator, it is going to be 2652. So now we have what? The heat of products, which is 2652. And we said the equation for bond energy is heat of reactants minus heat of products. So what's the heat of reactants? 2494 minus the heat of products, which is 2652. If you do it on the calculator, we are going to get negative 158. Pay attention in the exam. I know in the exam they ask it to 4 significant figures. So it's not going to be negative 158. It's going to be negative 158.0 kilojoules per mole. So the answer for the first CQD is negative 158.0 kilojoules per mole. Now, the second CQD. Given the following values for bond energies, I calculate the total energy change for the formation of ammonia. First of all, we are given what? We are given bond energies. We said anytime we see bond energies, we do heat of reactants minus the heat of products. All right? So step 1, find the total heat of reactants. We have 1 triple N bond plus 3 H single bond H. If we're going to replace it with the values, it becomes 1 times 945 plus 3 times 436. So on the calculator, we are going to get 2253. So now we have heat of reactants is equal to 253. Let us now find the heat of the products. We have 1, 2, 3, 4, 5, 6 times an H bond. So 6 times 389 kilojoules, which is 2334. So now we have the heat of products, which is 2, 3, 3, 4. And we said anytime we see bond energies, the reaction is heat of reactants minus heat of products. What's the heat of reactants? 2253 minus the heat of products, which is 2334. If we do it on the calculator, it's gonna be negative 81 kilojoules per mole. Please guys, pay attention to how many significant figures they ask it. Here there's no specific amount, but if they ask you to 3 significant figures, it would be negative 81.0. Now this was part I. Part II. State clearly whether the reaction is endothermic or exothermic. We said if delta H is less than 0, it is exo. However, if delta H is greater than 0, it is endo. So consequently, we can say our delta H over here, or the bond energy that we found, was negative 81. Negative 81 is less than 0, so delta H is less than 0. So consequently, it is exothermic. That was CQD number 7. Now, exercise 1. So they asked us for this question to calculate the enthalpy change of the following reaction. Okay? If we notice, they are bonds and we have bond energy. So what is the rule for bond energy? Heat of reactants minus heat of products. So, look here. In the reactants, we have 1 C bond, okay, plus 1, 2, 3, 4, 5, 6 CH bond, plus 1 Cl bond. Okay, so that means the heat of reactants, if we replace it by values, is going to be 1 times 286 plus 6 times 413 plus 1 times 243. So 1 times 286 plus 6 times 413 plus 1 times 243, it's gonna be 3007. So now we found the heat of reactants, 3007. Let us now find the heat of the products. Heat of products is equal to, we have 1 C bond, we have 1, 2, 3, 4, 5, so plus 5 CH bond plus 1 CCl bond plus 1 HCl bond. If we're gonna replace it by values now, it's gonna be 1 times 286, okay, plus 5 times 413 plus 1 times 346 plus 1 times 432. So if we do it on the calculator, 1 times 286 plus 5 times 413 plus 1 times 346 plus 1 times 432, we are gonna get 3129. So what is the rule of bond energy? It's heat of reactants minus heat of products. So it's gonna be 3007 minus 3129. So 3007 minus 3129, we are gonna get negative 122 kilojoules per mole. That's part A. Let's do part B now. Determine the enthalpy change for this reaction. Okay, again we have bond energy. What is the rule of bond energy? It is the heat of reactants minus the heat of products. So we have 1, 2, 3, 4 CH bonds, so 4 times CH bond plus 2 times O double O bond. So this is what? our heat of reactants. So heat of reactants is equal to 4 times CH, which is 413, plus 2 times OOO, 2 times 498, which is then what? If we do it on the calculator, we are gonna get 2648. So we found the heat of reactants, which is 2648. Now, let's find the heat of the products. We have 2 times COO bond plus 2 times 2 times OH bond. So 2 times COO plus 4 times OH bond. If we're going to replace with the values, we're going to get 2 times 805 plus 4 times 464. 2 times 805 plus 4 times 464 gives us 3466. So now we have the heat of products, which is 3466. So our equation is now heat of reactants minus heat of products, which is 2648 minus 3466, and it will give us negative 818 kilojoules per mole. So that's exercise 1 done. Now we come to exercise 2. They told us, given us the molar heat of formation of CO2 is 393 kilojoules, the molar heat of formation of C2H6 is 884.5 kilojoules, and the heat of formation of H2O is negative 242 kilojoules. We need to find the heat of combustion of ethane to form water vapor and carbon dioxide. We said if they asked us bond energies, we would do heat of reactants minus heat of products. But whenever they ask us the heat of something, heat of formation, heat of combustion, heat of evaporation, heat of condensation, the heat of anything, what do? We do the heat of products minus the heat of reactants, only in the case if they ask us heat of combustion. Okay? So that means we need to find first the heat of the products, then we need to subtract it from the heat of the reactants. So what's the heat of CO2? It's 393 kilojoules, so heat of products is equal to 2 times CO2, which is 393 kilojoules, plus 3 times H2O, which is negative 242 kilojoules. If we're gonna do it, it's gonna be 2 times 393 plus 3 times negative 242. We are gonna get 60 kilojoules. So the heat of products is 60 kilojoules. Now let's find the heat of reactants. Heat of reactants is what? 1 times C2H6, so 1 times 84.5, okay, plus 7/2O2. Here is the thing. The heat of an element we never considered, so 7/2O2 is not considered. As in 19 it says, the heat of formation of an element under standard condition, an element which is O2 is 0, so plus 0. Again, they gave us an element, so we're gonna put 0 for the heat. It's only in the heat of formation or heat of combustion or heat of anything, you know? So the total heat of reactants is 84.5. So now to apply the rule, we have the heat of products, which is 60 kilojoules, minus the heat of reactants, which is 84.5 kilojoules. And we are gonna get negative 24.5 kilojoules. So that's exercise number 2 done. Okay, so for exercise 3, they said use the given table to calculate the enthalpy change of the following reactions. They didn't say bond energies. The only case where we do reactants minus products is bond energies. Otherwise, we do what? Heat of products minus heat of reactants. Now, to find the heat of products and heat of reactants, for part A, first of all, we have NaCl plus H2O. NaCl is negative 411 plus H2O. H2O gas, pay attention, we need H2O gas, which is negative 241.8. We're gonna get that the heat of products is negative 652.8. Now, minus the heat of reactants. What's the heat of reactants? We have NaOH, solid, so minus 426.7, plus HCl, gas, which is negative 92.3. So we're gonna get negative 519. So minus 652.8 minus 519 is equal to negative 133.8. So the answer for the first one was negative 133.8. Part B. Again, heat of products minus heat of reactants. What's our product? It is CO2 gas. So we search for CO2 gas. It's over here. And it's negative 393.5, but times 2, because we multiply by the coefficient. So 2 times negative 393.5. Okay, it's gonna be negative 787. This is what? This is the heat of products. Now minus the heat of reactants. To find the heat of reactants, we have O2 gas. We remember that if they ever give us an element, we do not consider it. We consider the heat of formation to be 0. Okay, and then we have 2CO gas. CO gas is negative 110.5. So 2CO gas would be 2 times negative 110.5, which is negative 221. So minus 787 minus 221 is equal to negative 566. So the answer here is minus 566 kilojoules per mole. Part C. In part C, we have, first of all, heat of products minus heat of reactants. In part C, we have H2O liquid, 2 H2O liquid, so negative 285.8 times 2, okay, plus CO2 gas, which is negative 393.5. So the heat of products is negative 965.1. Now, minus the heat of reactants, we have again an element which we will not consider. Then we have CH4 gas. CH4 gas is negative 74.8. So the answer is gonna be minus 965.1 minus 74.8. We are gonna get then negative 890.3. So the answer for the third one is negative 890.3. Now the fourth one. We have again the equation heat of products minus heat of reactants. Okay? What is our product? We have here 2 SO2 gas. So this times 2 plus 2 H2O liquid. So where is H2O liquid here? Times 2. So it's gonna be negative 285.8 times 2 plus negative 296.1 times 2. So we are gonna get heat of products is negative 1163.8 63.8 minus the heat of reactants. Again, we have an element. We do not consider the element. And we have 2H2S. So this times 2. So it's going to be negative 20.1 times 2. So minus 40.2. So the heat of formation is going to be negative 1163.8 minus 40.2. So we are going to get then negative 1123.6. So the answer for the fourth one is negative 1123.6. Now, the last one, we have again heat of products minus heat of reactants. The product is 2NO2 gas. So times 2, we're going to have 33.9 times 2, which is 67.8 minus the heat of our products. We don't consider the elements. So 2NO gas. This is NO gas. So times 2 minus 90.4 times 2, which is 180.8. So if we are going to solve it, it's going to be 67.8 minus 180.8. It's going to be negative 113 kilojoules. Now, we notice that in all of them, the heat of reactants was less than heat of products except for part E. Alright? Now, of course, the heat of products was negative in all of them. So in A, B, C, D, the heat of products was negative. That's why we got a negative result. But in E, the heat of products was positive. So then the heat of our reactants was bigger. So here in E, heat of reactants was greater than heat of products. So then what can we say? We can say that the heat of products minus the heat of reactants was definitely a negative number. So that was for exercise number 3. Now, here we are. We reached what? Calorimetry. Whenever you see. So again, whenever we see the word calorimetry, we have only 2 equations. Q is equal to M times C times delta T. Okay? Where Q is the energy released, M is the mass, C is the energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius, and delta T is the change in temperature. Our second equation is then negative Q over N, okay? And if we expand it, it's going to be negative C times delta T over mass divided by molar mass. Now we're going to apply. We're going to see which one of the 2 we're going to apply. It takes 0.71 joules to raise a temperature of 1 gram by 1 degree Celsius. Directly, we know this is our C. Calculate the energy required. Energy required is always Q, okay? To what? To raise the temperature of 1 mole of graphite. You should know that 1 mole of graphite, which is carbon, is equal to 12 grams. So now we have our mass. By what? By 2 degrees Celsius. Okay, but this is to raise the temperature by 2 degrees Celsius. So we can say this is our delta T. So we have C, we have mass, we have delta T, and we need to find Q. So we're going to use the equation Q equals M times C times delta T. Again, we have C, we have to find the Q, we have our mass, which is 12 grams, and we have our delta T. So all we need to do is substitute. So Q that we need to find is equal to 12 grams. In chemistry, always the mass is in grams, times C, which is 0.71 joules, times delta T, which is 2. So if we're going to do it, 12 times 0.71 times 2, we are gonna get 17.04, which is approximately 17. So the first one is 17. Now we can continue the full question using this equation: Q equals M times C times delta T. So we need to find the Q. Okay, we know that our C is 0.71, but we need to find the Q to raise the temperature of 24 grams. This is our mass by 5 degrees Celsius. This is our delta T. So it's gonna be 24 grams times 0.71 times 5, and it is gonna be 24 times 0.71 times 5. It's gonna be 85.2, which is approximately 85. So the answer for the second one is 85. The first one was 17. Now these are all joules. Okay? Now the last one, pay attention. Again, we're using the equation Q equals M times C times delta T. Alright? Our mass is what? 36 grams. Our C is 0.71 joules. We need to find the Q. But here they told us to raise the temperature from 249 Kelvin to 296 Kelvin. We know that the degree, how much you increase the temperature, is the same for degrees Celsius and Kelvin. Meaning, if you have 294 Kelvin to 296 Kelvin, you increased by 2 degrees. It would be the same if you converted them to Celsius. So what is our delta T? Our delta T is 2 degrees. So now that we have everything we need, we can substitute. Q that we need to find is equal to 36 times 0.71 times 2 degrees. So then we are going to have 36 times 0.71 times 2. It's going to be 51.12, which is approximately 51. So in order, we have 17 joules, 85 joules, and 51 joules. That is for CQD number 8. Now we have CQD number 5. We said whenever we see calorimetry or calorimeter, we have two equations, which is Q equals M times C times delta T, or negative Q over N. Let's see which one we're going to use here. To change the temperature of a particular calorimeter. Calorimeter means we use either this one or this one. And the water it contains by 1 degree. We're raising the temperature by 1 degree, okay, is 5 kilojoules. So this is our C. To raise the temperature by 1 degree, it is 5 kilojoules. So for now, this is our C. The complete combustion of 0.7 gram. 0.7 gram is our mass. Okay? The temperature rises by 5.3 degrees Celsius. So this is what our delta T. Find the heat of combustion. Did they ask us to find the heat required, the energy required, or they asked us to find the heat of combustion? No, they asked us to find the heat of combustion. So anytime they ask you to find the heat of combustion, heat of formation, heat of anything, we use, if it's calorimeter, we use negative Q over N. We have over here our molar mass. So negative Q over N, it can be expanded into negative C times delta T. Only in this case is Q C times delta T. So negative Q is equal to negative C times delta T in this case, only if it's over N. And then N from previous years is the mass over molar mass. So now let's substitute. Negative 5 kilojoules times 5.3 degrees Celsius over 0.7 times, divided by 28 will give us, let's do it on the calculator, negative 1060 kilojoules per mole. So pay really close attention to understanding the question to know which equation to use. Now, exercise number 4. Write the reverse of the equation. 2C solid plus 3H2 gives us C2H6. Whenever they tell us reverse, that means multiply by, that's not 2, sorry, I was trying to do curly bracket, multiply by negative. Okay? Reverse means multiply by negative, and if we multiply one part of the equation by negative, the whole thing gets affected, even the delta H. So to reverse this reaction, we're gonna multiply it by negative here and here. So if we multiply the reaction by negative, it's gonna flip. It's gonna be C2H6 gas gives us 2C solid plus 3H2 gas, okay? And delta H, because we multiplied it by negative, it becomes 84.5 kilojoules. Nothing simpler than this, okay? Now, exercise 5. We are given 3C solid plus 2Fe2O3 solid plus 462 kilojoules gives us 4Fe solid plus 3CO2 gas. They're telling us rewrite the equation expressing delta H as per mole of Fe. So what are they basically asking us? They're telling us rewrite this equation, but Fe is 1 mole. Here, if you look, it is 4 moles. So how does 4 moles become 1 mole? We divide it by 4. And we said if we divide or we do anything to one part of the equation, the full equation will be affected. So that means you're going to divide everything by 4. So now it's going to be 3 over 4C plus 2 over 4 Fe2O3 plus 462 divided by 4 is 115.5 kilojoules, will give us 4 divided by 4 is 1, so 1 Fe plus 3 over 4 CO2. Very logical, very simple. Second part, part B. Rewrite the equation expressing delta H as per mole of C. What do we mean by mole of C? That means C has to be 1 mole. Here it is 3, let me write it properly, it looks like M, 3 moles. How does 3 moles become 1 mole? If we divide it by 3. So, rewriting the equation expressing delta H as per mole of C, we need to divide the full thing by 3. So now it becomes C plus 2 over 3 Fe2O3 plus 462 divided by 3, 154 kilojoules, gives us 4 over 3 Fe plus 3 divided by 3 is 1 CO2 gas. Very simple, we got our answer. Now, CQD number 1. They're telling us rewrite the equation expressing the coefficients of the smallest whole numbers. What does it mean? Smallest whole numbers means no fractions, no decimals or radicals. Of course, we're not going to see decimals and radicals in chemistry, but just to say what the smallest whole number means. So for now, it means no fractions. Okay? So, given 1 over 2 H2 gas plus 1 over 2 Br2 liquid gives us HBr gas. How do we change 1 over 2 into a whole number? How about we multiply it by 2? If we multiply 1 over 2 by 2, that means we multiply the full equation by 2. So even the delta H is going to be multiplied by 2. Okay? Now, if we multiply by 2, we are going to get H2 gas plus Br2 liquid gives us 2 HBr, and our delta H is going to be negative 72 kilojoules per mole. They asked us, express the heat of reaction per mole of H2. Per 1 mole of H2, the heat of reaction is negative 72 kilojoules per mole. Now they're telling us how much energy is liberated, how much energy is freed. Since it is a negative number, we're gonna put it in the side of the product, so plus 72. So that means what? It is exothermic. So if it's liberated, it is freed, it is in the product, it's exothermic. When 2 moles of HBr are produced, how much energy is freed? It is 72 kilojoules, not negative 72, it is 72 kilojoules. So that was it for CQD number 1. CQD number 2. Consider the following reaction. Calculate the heat, oh my goodness, okay. Here we saw decimal. So again, a whole number cannot be fraction or decimal. In chemistry, we can see decimals, okay? But anyways, let me read the equation properly to understand what they mean. We have this reaction. Calculate the heat change when 1.6 grams of methane is burned in excess oxygen. Okay, what is methane? Methane is CH4 gas, okay? Now they're telling us 1.6 gram of methane is burned in excess oxygen. The molar mass of methane is 12 plus 4, 16 grams. Okay, so now we have the molar mass. They're telling us in this equation, it's balanced. You have to always make sure it is balanced, that 1 mole of methane, which is 16 grams, gives us negative 819 kilojoules. Now, when 1.6 grams of methane is burned in excess oxygen, let us think of it this way. 1 mole give us 16 grams. طيب, how much will 1.6 grams give us? This is stoichiometry from last year. You do cross multiplication, you are gonna get that 0.1 mole gives us 1.6 grams. So that means the CH4 went from 1 mole to 0.1 mole. Okay? If delta H for 1 mole of CH4 is negative 819 kilojoules, how about for 0.1 moles? Very simply, we multiply it by 0.1 moles, and we're gonna get negative 81.9 kilojoules. Guys, if there's any CQD not explained, like you didn't feel I explained it properly, or I did a mistake in it or anything, please message me, tell me which CQDs, and I'll repeat them. Okay? So negative 81.9 kilojoules. CQD number 3 is very, very important. Please pay attention. Find the heat of combustion. Anytime you see combustion, that means plus O2. Of ethane, the equation of ethane is C2H6, okay? Forms water vapor, so H2O gas, and carbon dioxide plus CO2. They're telling us, find the heat of combustion, find delta H. First of all, is it balanced? It's not balanced. You guys have to balance it on your own. So I'll just give you the final balanced form, which is C2H6 plus 7 over 2 O2 gives us 3H2O plus 2 CO2. Okay? Now we start. Here's where I need you guys to focus very, very well. We have C2H6. We have it in the reactant side. Now we look at these equations. Which equation has C2H6? The last equation. Now, is it in the reactant side or in the product side? It's in the product side. Unlike what we need the C2H6 to be in the reactants. So how do we change it? We multiply it by negative, or we reverse it. Now we check C2H6, we have 1 mole. And also here C2H6, we have 1 mole. So we don't need to multiply it by anything else. That's C2H6 done. Then we have 7 over 2 O2. We have O2 over here and we have O2 over here. If we ever have any compound or element that is in more than one reaction, we will leave it for last because it will balance itself out. Okay, now the 3H2O. Which equation has H2O? This equation has H2O. Now, for us, H2O is in the reactants. Is the H2O here in the reactants? Yes. But here we have 3 moles of H2O, whereas here it's 1 mole of H2O. So how do we make it into 3 moles, we multiply the full thing by 3. Okay? Now, finally, we have the 2 CO2. Which equation has CO2? This equation has CO2, over here. For us, it's in the products. Is it in the product? Yes, so we keep it. But here we have 2 moles of CO2, and here we only have 1 mole of CO2, so we're gonna multiply it by 2. Now let us write the final equations. It's gonna be, for this one, it's gonna be 3H2 plus 3 over 2 O2 gives us 3H2O. For this one, it becomes 2C solid plus 2O2 gives us 2CO2. And now finally, this equation, we're only gonna flip it. It's gonna become C2H6, okay? Gives us 2C plus 3H2. Now, very important step over here. We have C2H6. Can we find it here? Yes, so we're gonna circle it. Then we have the O2s. We're gonna circle the O2s, we're gonna keep them. We have 3H2O, we're gonna circle the 3H2O, we're gonna keep it. And finally we have the 2CO2. We're gonna circle the 2CO2 and we're gonna keep it. Now everything else, what are they? We have 3H2 in the reactants and 3H2 in the products. Because they are in opposite sides, we can subtract them. So 3 minus 3 is 0. They go away with each other. Now, they cancel each other out basically. Then we have 2C in the products and 2C in the reactants. So 2 minus 2 is 0. They will cancel each other out. So now we are left with C2H6 plus 3 over 2O2 plus 2O2 gives us 3H2O plus 2CO2. If we add these together, you can do it on your calculator, you can do it mentally, or however you like to do it, even on paper, you are gonna get 7 over 2O2. So C2H6 plus 7 over 2O2 gives us 3H2O plus 2CO2. And just like that, we got the 2 balanced equations. But this isn't even our question. The question was to find the heat of combustion. How do we find the heat of combustion? We're gonna take all of the delta H's and we're gonna add them with what we changed. So it's now gonna be negative 242 times 3 plus negative 393 times 2 plus negative times minus 800 and minus 84.5. So if we do it on the calculator, we are gonna get negative 1427.5, and if we round it, it's gonna be negative 1428 kilojoules per mole. That's part A done. Now we have what? We have part B. The thermite reaction is a spectacular and highly exothermic reaction. It involves the reaction between Fe2O3 plus metallic aluminium. Okay? It will produce white hot molten iron. So it's gonna produce Fe plus Al2O3. Now, you're not supposed to memorize this. They're gonna give it to us in the exam. Don't worry. This one, I got it from the internet. Okay? So anyways, it's not in its balanced form. How do we balance it? We're gonna put really easily A2 next to the Al and A2 next to the Fe. So now, this is the equation we need. So we have Fe2O3, alright? We're gonna search for Fe2O3 in these 2 reactions. We have over here Fe2O3. Us, we need Fe2O3 in the reactants, but here it's given in the products. So to make it in the products, we're gonna reverse it by multiplying by minus. Another thing, here we have, so again, I'm sorry if I keep on cutting off. So we have one Fe2O3, but here we have two Fe2O3s. So how do we change the two into one Fe2O3? We can multiply it by 1 over 2 or divide it by 2, however you like to put it. So we are done with the Fe2O3. Now the two aluminium, we need aluminium to be in the reactants. Which equation has aluminium? This one. It's already in the reactant, so we keep it as it is. Now, what's the issue here? Is that we have 4 aluminium, but we need 2 aluminium. So we're only going to multiply it by 1 over 2. Let's write now the resulting equations. We're going to have 2 aluminium plus 3 over 2O2 gives us Al2O3. And here we are going to have Fe2O3 gives us 2Fe plus 3 over 2O2. Now, why did I not do the products? Because if you notice, they're already balanced. 2Fe is 2Fe, Al2O3 is Al2O3, and they're both in the product side. So now, we need what? We need the Fe2O3, so we're going to circle it. We need the 2 aluminium, we're going to circle it. We need the 2Fe, we're going to circle it. And we need the Al2O3. We're left with 3 over 2O2 in the reactants and 3 over 2O2 in the products. You can subtract them, they will cancel out, and you will get 0. So now, what do we have? We have 2Al plus Fe2O3 gives us 2Fe plus Al2O3. Now this isn't the point of the solving. The point of the solving is to get the delta H. So how do we get the delta H? We do delta H1, which is negative 3348 times 1 over 2, okay? And we're gonna add it to delta H2, which was minus 1674 times minus 1 over 2. If we do it on the calculators, we're gonna get minus 3348. So we are gonna get negative 837 kilojoules per mole. So the heat is negative 837 delta H. Okay? Now determine the amount of heat liberated. Whenever they ask for the amount of heat liberated, we know it is negative, so it's exothermic. It's gonna be in the product side. So the amount of heat liberated, the amount of heat that's on the product side is 837, not negative, because if you write the equation, it's gonna be reactants gives us products plus 837. So 837. CQD 4. Here this one is the same as before but simpler. Calculate delta H for the reaction. NO gas plus O gas gives us NO2 gas. We have NO2 gas in the reactants, in the products, and then we have NO2 gas in the products. So we're not gonna change this equation. Then we have NO gas in the reactants, and we have NO gas in the reactants. We're not gonna change anything. Now here's the thing, we have O gas. O gas, we have 2O, okay? And it is in the products, whereas for us we have O gas in the reactants. So how do we make it? How do we change it? We're gonna multiply it by negative first of all to make it into the reactants, and then by 1 over 2 to make it what? To make it O gas. So now we're gonna have O gas gives us 1 over 2 O2. Okay? Now what do we need in the, first of all, let's write the equations. We have 2O3 gives us 3O2, okay? Then we have O gas gives us 1 over 2O2, okay? Then we have an O gas plus O3 gas gives us an O2 gas plus O2, okay? Now, please pay attention. We need to circle the things that we need. We need the NO, we need the O, this is gas, and we need the NO2. So everything else we need to find a way to remove them. Now, what do we need to remove? We need to remove the 2O3 and the O3, and the 3O2 and the 1/2O2 and the O2. But this is very, very tricky. Why? Because we cannot touch this one. We cannot touch this one because they will affect what we need for our reaction. So what's the only equation we can touch? We can touch this one, okay? So how are we gonna touch it so that it will, how are we gonna change it so that it will help us achieve what we need over here? First of all, to get rid of the O3, okay, we need to put it in, we need to put the 2O3 in the products. So we are gonna multiply it by negative. Okay, now that we multiplied it by negative, we have 3O2 gives us 2O3. Okay, what's the next step? The next step is O3. It is 1 more. Then we need 2O3 to become 1 more. So we're gonna multiply it by 1/2. That means our equation is no longer this, it is now 3/2O2 gives us O3. So now, if we're gonna rewrite it, this is times -1/2, this is times -1/2, we're gonna have 3/2O2 gives us O3. Then we have O gives us 1/2O2. Then we have an O plus O3 gives us NO2 plus O2. Okay? Now, we need the NO, we need the O, we need the NO2. Everything else we have to remove them. Let us try subtracting, or let's try subtracting and adding. We have 3/2O2. In the product side, we have 1/2O2 plus 1O2. Now, if we have reactants and on the product side, we can subtract them. So, if you are gonna do it, it will become 3/2O2 minus 3/2O2. So then, what did we find? We found out that this plus this is equal to this, and because one is in the reactants and one is in the products, they will subtract and give us 0, or they cancel each other out. We also need to remove the O3. We have O3 in the reactants, O3 in the products. They are the same number of moles, so we can remove them. So very simply, we found our equation, which is NO plus O gives us NO2. Now, the point of this equation is to find what? The heat. So to find the delta H, we're gonna add them all with the changes. So it's gonna be minus 427 times minus 427 times minus 1/2. Okay, plus 495 times minus 1/2. Okay, plus minus 122. If we're gonna do it on the calculator, we are gonna get negative 156 kilojoules. So that's it for CQD number 4. CQD number 9. Find delta H for the manufacture of diamond from graphite. We need C graphite gives us C diamond. Which equation has graphite? This equation has graphite. It is in the reactant, so we keep it as it is, and it is 1 mole, so we also keep it as it is. Okay? Then, for C diamond, which equation has C diamond? The first one, but we need it in the products, it's in the reactant, so we're gonna reverse the reaction by multiplying by negative. Now, 1 mole of C diamond and 1 mole of C diamond, so we're not gonna change anything. So for the delta H, we're gonna add them with their changes. So now it's minus 395.4 times negative, okay, plus minus 393.5. So it is now minus 393.5 plus, because minus times minus gives us plus, plus 395.4. And so what is our delta H? Our delta H is plus 1.9 kilojoules. So since it is positive, that means it is endothermic. So is the heat absorbed or evolved? Absorbed means endo, evolved means exo. So definitely, because it's positive, it's endothermic, and because it's endothermic, that means the heat is absorbed. So that's CQD number 9 done. Now we have CQD 10. Calculate delta H for the reaction. This from the following data. First thing, C2H4 gas, 1 mole, and it is in the reactants. Which equation has C2H4? This one. Is it 1 mole? Yes, it is. Is it in the reactants? Yes, it is. So we keep the whole equation as it is. We're not supposed to change anything. Second one, H2 gas. We have this equation has H2 gas. It is 1 mole and it is in the reactants. So we're supposed to keep everything as it is. We're not supposed to change anything in the reaction. Now finally, we have C2H6 over here. It's 1 mole and 1 mole, but here it is in the reactants, but we need it in the products. So to make it to the product, we're gonna multiply it by negative. Okay? So let's write the equations now. It's gonna be C2H4 plus 3O2 gives us 2CO2 plus 2H2O, and then 2CO2 plus 3H2O gives us 3.5 O2 plus C2H6. I don't know if the last one will fit, but let's try. And then H2 plus 1 over 2 O2 gives us H2O liquid. H2O. Okay? So let's circle the things we need. We need C2H4. We're gonna circle it. We need H2. We're gonna circle it. We need C2H6. We are gonna circle it as well. So we need to keep everything that is circled. Everything else, we need to cancel it out. Or like subtract. Meaning, us, we have what? We have 3O2 in the reactants plus 1 over 2 O2 also in the reactants will give us what? 3.5 O2 in the products. So because we have the same coefficient of O2 in the reactants and the products, then we can cancel them out because they will subtract and give us 0. Then we have 2 CO2 in the reactants gives us 2 CO2 in the product, so they will cancel out. Or like if you subtract them, they will give you 0. Now finally, we have 3H2O gives us 2H2O plus H2O. So again, it's the same coefficient in the reactants and the product, so we can cancel them out. So the only thing we changed in this reaction was negative here. So if we're gonna apply it, it is gonna be minus 1411 plus minus times minus 1560 plus minus 285.8. If we do it on the calculator, So then we are gonna get negative 136.8, and if you round it, it's gonna be negative 137. That's it for question number 10. Question number 11. CQD number 11. Calculate delta H for the reaction 4NH3 gas plus 5O2 gas gives us 4NO gas plus 6H2O gas. First things first, we have NH3. Which equation has NH3? This one. Is it in the reactants like we need it, or in the products? It's in the product, so we have to multiply it by negative to reverse. Second thing, the coefficient we need is 4, but the coefficient we are given is 2. So we're going to multiply it by 2. So we multiply this equation by negative 2. Next, 5O2. We have O2 in more than one equation. If you ever have anything in more than one equation, especially O2, CO2, H2O, if you have anything like that, leave it alone. It will solve itself. It will sort out. It will balance itself later. Okay? 4NO gas. Which one has NO gas? This one. It has NO gas in the products, just like we need it. So we're not going to reverse it. And the thing is, we needed 4NO. It's giving us 2NO. So to make it 4NO, we're going to multiply it by 2. Now, we need 6H2O. Which one has H2O? This one over here. It is in the products just like we need it, so we're not going to reverse it. But we need 6, and here it gave us what? It gave us 2. So to make it 6, we're going to multiply it by 3. Now, let us write all the equations. We're going to have 2N2 plus 2O2 gives us 4NO. Okay, then we're going to have 4NH3 gives us 2N2 plus 6H2. Okay, and then here we're going to have 6H2 plus 3O2 gives us what? It gives us 6H2O. Now, let's circle the ones we need. We need the 4NH3. We're going to circle it. We need the 5O2. So we're going to circle this O2 and this O2. We need the 4NO. So we're going to circle the NO. And we need the 6H2O. So we're going to circle it. Everything else will cancel out. 2 and 2 will cancel. We'll subtract it from 2 and 2. It will be 0. So it will cancel out. Then 6H2. We will subtract it with 6H2. So it will be 0. And it will cancel out. So we are left with what? 4NH3 plus 2O2 plus 3O2, which is 5O2. You see, it balanced out. Gives us 4NO plus 6H2O. To find, now the main reason we did this was to find what? The delta H. To find the delta H, we're going to add all the values with their changes. So it's going to be negative 180.5 times 2. Plus negative 2 times negative 91.8 plus minus 483.6 times 3. So let's do it together on the calculator. Minus 180.5 times 2 plus minus 2 times 91.8 plus negative 483.6 times 3. So we are gonna get minus 1628.2. If we round it, it's minus 1628 kilojoules. That's CQD number 11 done. Now, exercise 6 is very big, but I will do it. I will do it quicker now since it's easier for us to do it. Okay, calculate the value of delta H of the following reaction. We have C solid. Okay, we need C solid in the reactant. So which equation has C solid? This one. Okay, then we need O2. We have O2 in more than one place, so we're going to keep it as it is. Then we need CO2 in the reactants. We're also going to keep it as it is. If you noticed, we don't need to change anything. So, since we didn't change anything, let's just write it. Or let's keep it here. You don't need to write it. Okay, we have the H2O will cancel with the H2O. The H2 will cancel with the H2. The CO will cancel with the CO. We will be left with C plus 1 over 2 plus 1 over 2, which is 1 O2, gives us CO2. So directly like this, what did we find? We found out that directly here, we can directly add them because we didn't change anything. I think I said directly like 5 times. So it's going to be 131 plus minus 282 plus minus 242. So we're going to have minus 393 kilojoules. That's for part A. Part B. Given the following data, calculate delta H of the reaction. So to do it quickly, we need 2 N2 gas. This one has N2 gas, so we're going to multiply it by negative 4y because we need to reverse it and we need the coefficient to be 2. Then we need the 6H2O, so we're going to bring it over here. We're going to multiply this one by negative 3y because we need to reverse it and we also need the coefficient to be 6. So then if we're going to write the new equations, they are going to be 2N2 plus 6H2 gives us 4NH3. And the second equation is gonna be 6H2O plus, sorry, without plus 6H2O gives us 3O2 plus 6H2. So let's cancel the ones that can be cancelled, the 6H2 and the 6H2. So now we are left with what? 2N2 plus 6H2O gives us 4NH3 plus 3O2. Is it the equation we need? Yes. So to find the delta H, we're gonna add all the delta H with their changes. So it's gonna be 46 times minus 4 plus minus 484 times minus 3. So 46 times minus 4 plus minus 484 times minus 3. So then the delta H of the reaction is gonna be 1, 2, 6, 8. That's part C. Sorry, that's part B. Now part C. Now we have C. We have to calculate the delta H for PCl3. This over here. This has PCl3, so we are gonna multiply it by 1 over 4. Then we have Cl2. We have it in 2 equations, so we're gonna leave it. Then we have PCl5. I'm doing this fast because I'm pretty sure you guys know how to do it. Over here, we're gonna multiply it by negative 1 over 4. So now the equation is gonna be PCl3 gives us 1 over 4 P4 plus 6 over 4 Cl2. And here it's gonna be 10 over 4 Cl2 gives us 10 over 4 Cl2 plus 1 over 4 P4 gives us PCl5. So the ones we need are PCl3, Cl2, and PCl5. So we circle PCl3, PCl5, and the Cl2s. This will go away with this. And so now we subtract. We do 10 over 4 because it's in the reactants minus the one in the products. 10 over 4. So the 10 Cl2 minus the 6 over 4 Cl2. We will then get 4 over 4 Cl2, which is 1 Cl2. So now the full equation is going to be PCl3, okay, plus Cl2 gives us PCl5. So that's for part C. Now, finally for part D, okay, let's do part D. Given 4H2O liquid, blah blah blah, we need to find 2NH3 gas gives us N2 gas plus 3H2O gas, 3H2 gas, my bad. So now this means that the delta H of the reaction is 300 times 1 over 4 plus 900 times negative 1 over 4. So if we're going to do it on the calculator, 300 times 1 over 4 plus 900 times negative 1 over 4, we're going to have negative 150 kilojoules per mole. Now, D, given 4 2H2O liquid plus this blah blah blah, calculate delta H for 2NH3, which equation has an H3. This one, it is already in the reactants just like we need it, yeah, and the coefficient is 2, so we don't need to change anything in the first equation. Now the second equation, we need N2. We have N2 in the second equation, right? But we need N2 in what? In the products, and it's given to us already in the product, so we don't need to change anything. And the H2, as you see, we have H2 here and we have H2 there. We have in the reactants and in the products in two different equations, so we will leave it, it will balance out by itself. So now we have 4H2O plus 2NH3 gives us 2NO2 plus 7H2, okay? And then we have 2NO2 plus 4H2 gives us N2 plus 4H2O. Circle the ones that we need. We need the 2NH3, we need the N2, and we need the 3H2. So we circle this H2 and we circle this H2. The rest we can remove them. So 4 minus 4 is 0, they will cancel out. 2 minus 2 is also 0, so they will cancel out. So now our equation is 2NH3, okay, gives us N2 plus we have 7H2 in the product side minus the reactant side, which is 4H2. So we do 7 minus 4. So now our equation is 2NH3 gives us N2 plus 3H2. It's exactly as we needed. We didn't change anything. So the delta H is going to be what? 400 plus minus 100. So it is then 300. So again, you can have it in any other way you want to do the experiment. Any way you know to do this experiment, you can put it as long as it's correct. But the way that is written, is that we are supposed to know and that I use, is that first step, measure volume of the dilute solution of barium hydroxide. Then the second step is to use a suitable container, okay? Then our third step is to, because it is an aqueous solution, because dilute solution, any solution is aqueous. Aqueous means it is in water. Because it's aqueous solution, because it has water, we need to measure initial temperature of water before adding the reactants, okay? Then, after measuring the initial temperature of water, we're gonna do what? We are gonna add the solid. Okay, Amanda cut that out. CQD number 13. When solid R and solid S separately react with barium hydroxide, one reaction absorbs energy and one reaction releases energy. So they want us to design an experiment to determine which process is endothermic and which process is exothermic, and which process has a greater energy change. So you are provided with a sample of solid R, a sample of solid S, a dilute solution. Dilute solution means aqueous, okay, and common laboratory apparatus. What can we do? the very first thing is that we need to do a separate reaction for solid R and a reaction for solid S. Aqueous means it is in water. First thing we're gonna do is measure volume of solution. So we need to measure the volume of our dilute solution of barium oxide. This goes for both of them. So this means the same thing. All right? Second step, we're gonna use a suitable container. Same here. Third step, I'll put it here. Okay? We're gonna measure temperature of water before reaction happens. So we're gonna have the temperature initial of water. After that, what are we gonna do? So I'm gonna label this 1, 2, 3, 4. I will fit it over here. After that, what will we do? We will add a known mass of either solid R or solid S. And then finally, step 5, we are gonna check final temperature of water. After this, we would have known which one is endothermic and which one is exothermic. Definitely, the one with a higher energy change would have, definitely the ones with a higher energy change would have a higher temperature, would have a higher temperature change. Okay? So the greater the energy change, the higher the temperature change. And endothermic, the temperature of surroundings decreased. Okay? Alright, so endothermic, the temperature of surroundings decreased, whereas exothermic, the temperature of surroundings increased. So, in summary, what did we do? We did an experiment for solid R and solid S separately. Okay, first we measured the volume of the solution, then we used a proper container, then we measured the initial temperature of water before we put anything. After that, we put the mass of either solid R or solid S, and then we checked the final temperature to see which one is greater energy change. Definitely the one that had a bigger heat change has the greater energy change. And definitely the temperature has to be increased if it's a greater energy change. And endothermic means the temperature of surroundings decreased, whereas the temperature of the reaction increased. And exothermic means the temperature of the surroundings increased, whereas the temperature of the reaction decreased. What does that mean? That means in number 14, use the thermometer diagrams for experiments 1, 2, and 3 to record the initial temperatures and final temperatures. Include whether the temperature increased or decreased in the temperature change. So in experiment 1, by looking, it's 25 degrees Celsius initially and approximately 19 degrees Celsius finally. In experiment 2, however, it is 25 degrees Celsius initially and almost 32 degrees Celsius finally. And experiment 3, it's 25 degrees Celsius initially and 20 degrees Celsius finally. So for experiment 1, it was 25 and 19. For experiment 2, it was 25 and 32. And for experiment 3, it was 25 and 20. Now the temperature changes. From 25 to 19, we lost 6 degrees Celsius. From 25 to 32, we gained 7 degrees Celsius. And from 25 to 20, we lost 5 degrees Celsius. Now, part B. Which of the following experiments describes an exothermic process? When we're talking about exothermic, that means reactants gives us products plus heat. So definitely temperature of products is greater than temperature of reactants. Okay? So, if we applied the rules from before, we know if we're gonna find the temperature change, it's temperature final minus temperature initial. What's the final temperature? The final temperature of 2 was 32 minus the initial temperature, which was 25. Definitely, if it is exothermic, the final temperature has to be greater than the initial temperature. So then we're gonna get 7. That means what? Experiment 2 is exo. Part C. How would the temperature changes measured after 1 minute differ if the experiments were repeated with 100 centimeter cubed instead of 50 centimeter cubed? Okay, remember we said volume, okay, as it increases, the reaction rate decreases. So, if the volume is increasing by 100 centimeters, increasing by almost double, so we're doubling from 50 to 100, this is times 2. So we're gonna do the total opposite for the reaction rate. So the temperature change, instead of doubling, will half. Very simple. Experiment 3 was repeated using 10 grams and 15 grams of solid C. The results of the temperature changes are shown in the table below. Again, I apologize for the background noise. It's my brother and his friend. Okay. 10 is the gram. Okay, if we go here, for example, this is 5, this is 10, this is 15. If 10 gives us minus 10, how much will 15 give us? It will give us minus 15. And how much will 5 give us? It will give us minus 5. So if you see, this is our slope. Basically, since it is a table, we can do 10. How did it become minus 10? Times minus 1. So 15 will become x by multiplying it by minus 1. Okay? So that means x is minus 1. Another student prepares an identical solution that prepared in experiment 1 and measured its initial and final temperatures. He observed no changes in temperature. What did he do wrong? Now, what he did wrong was probably he waited too long. Okay? Because he's in a room. The room temperature is almost like 25 degrees Celsius, I'm gonna assume. So, if he did experiment 1 again, which was from 25 degrees Celsius to 19 degrees Celsius, and then he waits too long, for example, this takes 30 minutes, but then he waits another 30 minutes, the reaction will happen again, but this time it's gonna be 25 degrees Celsius. So it'll take like heat from the surrounding area. So he probably waited too long. F. Another student used a glass beaker instead of a styrofoam cup while conducting the experiment. Would his measurement be less or more accurate than the first student? If you use a glass beaker instead of a styrofoam cup, which one is more likely to lose heat to the surroundings? Which one doesn't like isolate or warm, keep the cup warm? Definitely the styrofoam keeps cup warmer. So the glass beaker will be less accurate because more heat is lost to surroundings. Okay? Now for step 2, how can he check the reliability of his results? He can repeat the experiment, he can compare with other students, or he can take the average of his results and the other students' results. So thank you guys for watching. This was chapter 8 CQD, the notes, and I hope you understood. Have a great day.